So anyway, I'll plug it in 2. It's 3 times 4, is that okay with you? Plus 10 plus 4, I guess that's 12 plus 10 plus 4, I guess this is 26, right you guys? Mm-hmm. By the way, that means that whatever this function is, when x is 2, y is 26. It's an input and an output. It's an ordered pair. It's a point on the graph. That's all true. All right, well then her question, the funny question, is what's f of p plus 2? So that's kind of funny, but the concept is everywhere there's an x, plug in a p plus 2. So she gets what she said. She said she gets 3 times p plus 2 squared, because she has to plug in p plus 2 for x. And then she has 5 times p plus 2, because she had to plug that in for x. And then plus 4. And so, you know, when you're plugging in a real number, you get a real number as an answer. When you're plugging in variables with p's in there, then you're going to get answers with p's in there. You know, you're not going to get a real answer. But anyway, that's sort of the answer, except maybe they want this simplified. And so, right. So you come into this class with certain algebraic skills, or we kind of assume you have certain algebraic skills, and these are some we assume you have, but I don't mind, you know, going over it, I mean a little bit, but you have to square a binomial. Squaring a binomial means, here, let's go off to my scrap paper, it's p plus 2 times p plus 2.
Okay.
And so how do you do that? Well, it's p times p squared, p times 2, 2p, 2 times p, another 2p, and then 2 times 2, which is a 4.
Okay, I did it right.
Good. And then those middle terms can combine into 4p, so now I'm combining like terms. So this is a lot of little algebra skills that, you know, come up in this class, but I don't start by teaching you how to do this stuff. We kind of just start assuming you know this, but anyway, anytime we run into stuff you need reminding of, I'll help you. But that, you know, the word for this is called foiling this out. Sometimes people say you're going to foil this out. You're going to, and the reason they use the word foil is for, I multiplied the first times the first, that's the F. I multiplied the outer times the outer, that's the O. I multiplied the inner times the inner, that's the I for foil. And then I multiplied the last times the last. You know, I don't know if that's your thing or not. I kind of, to me, it's more logical where when I say, I got to take it's kind of like double distribution. You know, if you have a 6 times x minus 3, you have to distribute the 6. Okay, well, if you have, watch this. If you have x plus 6 times x minus 3, you sort of have to distribute the 6 and the x. I mean, the x has to get multiplied by both those guys, and the 6 has to be multiplied by both those guys. We call that foiling it out, or multiplying it out, or multiplying 2 binomials, is the way we talk. But you did it correctly, you said. By the way, after I foil it out, there's a 3 waiting out there. There's a 3 waiting out there. And some students do this wrong. They put the 3 in there too soon. Look, the 3 is not squared. Right. So don't put the 3 in there early. You got to wait. We did it correctly. We had to foil out the p plus 2 first. It was squared. The 3 is not squared, so the 3 is waiting out front, and then it gets distributed. So now it's, if you don't mind, a 3p squared. Sorry. A 3p squared plus a 12p plus a 12. Are you guys okay with that? That's this over here. That's this guy foiled out times the 3. Distribute the 5. 5p plus 10. There's a 4 out there on the end. Combine like terms. That means p squareds add with p squareds. P's add with p's. Numbers add with numbers. That's combining like terms. So you never know. Well, so the answer is, if I combine some like terms, I'll call that 17p and 22, 26. I think I did this right. But it's a funny, the real exercise was, can you plug this into the function everywhere there's an x? And do you know how to FOIL things out? Right. You know, yeah. You know, one of the funny things about this class, and this is, I don't know, I like to save my videos for math and not a bunch of other stuff, but this class is funny. It's college algebra, and it's a kind of a funny class because you get students with a lot of various abilities. Some students are barely made it to college algebra, and good Lord, they're praying hard to get out of college algebra. I mean, it's tough, you know, they have tough on, you know, math can be tough on some people. Other people, just some counselor told them to take college algebra, but they're probably ready for pre-calculus or something else perhaps. So we get some various abilities going on in here, and I try to balance all that. And I try to tell you what is this course, kind of what's not this course, but I help you with any math you ever have. I'll help you with. But anyway, it is only day 1 or 2. If you think it's too easy, maybe. Well, anyway, you're in here now. You're in here now. So, any other good questions? Anybody? Any other good questions? Well, try some homework and see what happens. You might have questions, and like I said, maybe Monday would be a good day. Maybe after a long weekend, you get a chance to get into that My Math Lab. Maybe Monday or Tuesday would be a good day to open up the computer and do a little more homework. But I'm just going to move on then today, and I'm going to just, well, sort of, I don't want to really review 1.2. I'd like you to try that homework and see what happens. We went through those ideas. I really want to get into these lines. And so yesterday I said, you know, you can graph a line. One more time here. If I just say y equals negative 1/3 x plus 10, can we graph this line? And I guess I'm saying, I just want a quick graph. That's all I want. And I do want it to be fairly accurate. I guess I can. You know, I'm not that picky, but when I ask you to sketch a graph on a test or a quiz, maybe I give you an x and a y axis. Maybe I do that for you on the test or quiz, but maybe not. Maybe you have to do your own little x and y axis. No big deal. But then here's what we learned yesterday. Rather than making a chart and plotting a million points, if I know some stuff, I can do this quicker. And one thing I know is that this number, when it's in this form, this number is the y-intercept. So that's one point I know. On the y-axis, it starts at 10. So now, the other thing that I know is that this is a line. It's a linear equation, maybe, and it's a line. So I only have 1 point on that line. I can get more points if I do this thing that I said, you just do your slope. Or sometimes I say count your slope. But what is your slope, first of all? Thank you. The negative 1/3 is the slope. And if we think of that as rise over run, I like to think of it like that. And that, because it is a change in y is a rise. A change in x is sort of a run. That's the concept. And if the rise is negative, then you don't rise, you go down 1. So I will start at this point. I'll go down 1 and over 3. You guys, that's what slope is. Do you see it as clear as I see it? I see it real clear. Down 1, over 3. And that gets me to another point on the line, and I can do it forever because a line always has a constant slope. So I can go down 1 and over 3 forever and create millions of points, but to draw a line, you only really need 2 points. So there's a picture of it. And that's that's a nice, accurate picture, sort of. You know, one thing for accuracy, you want to make whatever, if you call this 1, 2, 3, see, I actually kind of did 2. If that's 3, then that's probably not 10, right? So my accuracy ain't 2, right? But what I was going to say is if you call this a 1, 2, 3, it helps if your x-axis is 1, 2, 3. I don't know. You don't want your x-axis to be 1, 2, 3, 4, whatever. drawing this, I might label this 2, 4, 6, 8, you know, that's kind of cool. The truth.
I was going to ask if we can do that in English.
Well, sure. So, and the truth is, you don't have to write. So I get students who do this. It's the y-intercept 17. I just go up here and I label it 17. I mean, you should pay attention to what I do and
That's great.
mimic me because I'm kind of good at this math. But anyway, some students do this. 1, 2, 3, 4, 5, 6, 7. I mean, I don't need 17 little marks. I just one mark labeled 17 is good, you know. But anyway, there is a way to try to be fairly accurate. So you guys know how to graph a line, huh? Cool. And in a way, maybe you came to us with those skills, but that's this is more part of this course. This is something I'm sort of trying to teach you, but I do sort of know that you know it in a way. Check this one out. Oh, and by the way, if I was asking questions, so not only sometimes I say graph the line, but I also like to ask questions sometimes, and I like to ask, what is the slope? Leave a little blank. What is the y-intercept? Leave a little blank. And sometimes, and you heard me say this yesterday, what's the x-intercept? And leave a little blank. So 2 of these are real easy, and the other one takes a little work, and that's almost true all semester, by the way. So what is the slope? We already said. The slope's negative 1/3. It's that number in front of x. Don't put the x. It's not the x. It's just the number in front of x. What is the y-intercept? 10? You know, I could just call it 10. You know, it is a point, though. And if it's a point, what would you call it? Thank you. 0, 10. The x-coordinate is 0. The y-coordinate is 10. That's what it is on the y-axis. And if I want the x-intercept, I know one thing about the x-intercept. The y-coordinate is 0, but I don't know what it is unless I go find it. And I taught you yesterday, how do you find an x-intercept? Always, all your life, if you want an x-intercept.
Y is 0.
Y is 0. So you let y equal 0 in the equation. You let y equal 0, and you solve for x, which takes a little work. In chapter 1, it's not that much work. When you proceed to chapter 3, it's a little more work, and so forth. But when you let y equal 0 and solve for x, this is pretty easy. Probably 30, huh? How do you do this? I'm going to move the 1/3 x over here. To solve for x, I think I want to multiply by 3. Do you guys agree? Mm-hmm. If I multiply by 3, I do get 30. Yeah, I'll be darned. That does make sense. If you're going down 1 and over 3, down 1 over 3, down 1 over, yeah, you're going to hit, it's way over here at 30. Cool. How do I write that here? 30, comma 0. On my test or quiz, I love to present a line to you like this. Check this out. That's a line. How do you know it's a line? Maybe I haven't done a great job of telling you what's a line. I mean, it's a linear equation if it's in this form, but this one's not really in that form. Could you put this one in that form? And by the way, what is that form? That form is y equals mx plus b. That's our slope-intercept form. So if you can put something in that form, then you know it's a line. Maybe you should just know it's a line if it's y to the first power and x to the first power. You know, as long as there's no squareds or cubes or square roots or divided by x or divided by y. I mean, you can get some nasty equations. A line is not very nasty. It's just a nice x and a y. Some numbers. So it's a linear equation. It'll be a line. But watch this. So this time I want to ask you the same thing. I would like a graph, and I would like the slope, and I would like the x-intercept, and I would like the y-intercept. I guess I did it in a different order here. Watch out for that. But and I want a graph. But so what would you guys do? What would you do? So you've been taught and trained to kind of work with this formula, and so he said right off the bat, and I bet you all of you think we should solve for y. And once, because then we get it in this form, and then we know how to talk and think, and we can see, when it's in this form, you can see the slope, you can see the y-intercept. Is that what you want to do? Put it in this form? I mean, what that means is this form is a y all by itself. So you got to do some algebra to get y by itself. Okay, let's try that. What would you do to get y by itself?
Move the x.
Move the 5x over. Okay, and a lot of students, thousands of students will do this. You move your 5x over. What does that leave you over on this side? Over on this, on the, what is it? What is it?
-4.
Thank you. -4y. Thousands of students will move. They'll move that over, and then they'll lose their damn negative sign. That's bad. So you're moving the 5x over, and what are you left with? -4y equals. What did we just do? We moved a 5x over, so I guess it's a -5x plus 15. Well, you're not too far from solving for y now. You're trying to solve for y. Get y by itself. One more move. Divide by 4. Or -4. Divide by -4. And so I divide by -4. I divide by -4. I divide by -4. That's the rule of algebra. Whatever you do to one side, you do to the other side. I got y by itself now. Those negative signs cancel, and I can call that 5/4 x. I like to put the negative sign kind of in the numerator, or just put it out front. This is -15/4 is what this is. Okay. Now I should be able to answer some questions, and maybe should be able to sketch a graph, I guess. That's what, right? Y'all said to do this. Y'all made me do this. Let's see. What did it, you know, I did see some weird faces. Maybe you don't like fractions. I know students don't like fractions. Fractions are decimals. Hey, if you have a calculator, you can make all these decimals. They're beautiful little decimals, by the way. There, just make these decimals. What is this? What is 5/4?
1.25.
1.25. If you just divide it, it's a what is 15/4?
3.7.
3.75. I mean, maybe you like that better. I don't know. If I want to start with my y-intercept, I can see that better than I can see that. I mean, I know where it is. Whatever. My y-intercept is -3.75. Is that okay with you? -3.75 is my y-intercept, and the slope is 1.25. That means I go up 1.25 and over. Hello? 1. My slope is 1.25, so I can go up 1.25 and over 1. I can go up 1.25 and over 1. Is this bothering you? This sounds like it's bothering you. I tell you what, forget that. Forget these decimals. Let's do this. Let's go to our y-intercept, -15/4. Guess what? -15/4 is -3 3/4. Okay, that's right here. -3 3/4. And now what? Now what do I do with my slope? I go up 5 and over 4. Well, I guess going up 5 and over 4 is the same as going up 1.25 and over 1. I guess it's the same. I'll do it. Up 5 and over 4. 1, 2, 3, 4, 5. 1, 2, 3, 4. Going up 5 and over the 4 is the same as going up 1.25 and over 1. There's my line. Yes, sir?
So when we do our quizzes and stuff, if we just label the main dots, it'll be pretty much good enough. Okay.
When I grade it, I'm kind of looking for accuracy if it does go through the right y-intercept. Roughly, if it goes through the right x-intercept, maybe, and roughly if it's got kind of the right slant to it. If you made it too steep, I might not like it if it's too steep or too shallow, which has to do with that slope going up 5 and over 4. We've got an accurate kind of slope here.
Okay.
Yeah. And not too harsh on you, but if it's a little crazily too steep, it might cost you a point or something. But, Any other questions at all? All right, so I went with the y equals mx plus b. Let's graph it that way. When I do that, I do have a bunch of this information. What is the slope? I can write the answer 5/4. I could write the answer 1. These are all the same, you guys. These are the same numbers. What's the x-intercept? I haven't done that yet. What's the y-intercept? Negative 3.75. You know, I don't mind writing negative 3.75. What did I tell you a few minutes ago, though? Well, it is a point. You know, I wrote just the number negative, but it is a point. So maybe I should write it as 0, comma, negative 3.75. Whatever.
Is that how you want to test
Well, I'm saying I want it like that, and now you're, am I going to take off points if you don't do that? Probably not.
Okay.
But, so now what are you going to do? Whatever you want, I guess. But, I mean, I'm happy you got the right number. You understand what the y-intercept is. But I'm trying to emphasize that it is a point. And its x-coordinate is 0. I think that's important. I'm trying to emphasize that. Anyway, and if I want the x-intercept, what do I gotta do? Try to solve for x? Might be pretty easy, actually. Oh, well, I gotta let y equal 0 and solve for x. I can do it right here with these decimals. I can do it right here with these fractions. I'd rather do these decimals. I'd rather let y equal 0 and try to solve for x. Right, you guys? To find an x-intercept. I'm going to add this to the other side, 3.75. This is my little bit of algebra. This is easy basic algebra. Move the 3.75 over, 1.25x, divide. Now you divide by 1.25. You can pick up a calculator, but it goes in very easily. It goes in 3 times, I think. I think x is 3. The actual x-intercept is 3. Over here in my little chart, or my little answer here, I'm going to put 3, 0. Over here on my graph, I'm going to label that a 3. Okay. Everybody okay? Any other questions? Listen, so we've learned the value of this y equals mx plus b and how to use it. That's awesome. But I want to show you something. Okay, because I would not do this problem like this. I asked you how you would, and I went with what you did. I just want to show you something. Watch this. Same problem. Same problem, same problem, same problem. I'm asking you for the slope, I'm asking you for the x-intercept, I'm asking you for the y-intercept, and I'm presented this line like this. So here's how my brain works. I go like this. Oh man, I see these x and y intercepts, and I know how to find x and y intercepts. In order to find an x-intercept, I let y be 0. Watch this. I let y be 0. I plug in a 0 for y. Watch how I do that. Right? I mean, that's 0. If I plug in a 0 for y, that's a 0. You divide by 5, you divide by 5, x is 3. So I very quickly got the x-intercept. Did you see that? Okay, now, I want the y-intercept. Guess what I do? If I want the y-intercept, I can let x be 0. So I just let x be 0. I divide by -4, I divide by -4, and I get y, which is negative 15/4. Or, you know, you guys with me? I divide by -4, I divide by -4, I get negative 15/4. And so now I have the x and y intercept, which means I can get a good looking graph. Watch. The x-intercept is 3. The y-intercept is negative 3.75. And there's the line. So the only thing I skipped over, though, was the slope. And I don't really know the slope. Maybe, to tell you the truth, to get the slope, you know what I would do? See, I skipped over the slope. Because I can get an X and a Y intercept fast and easy. When it's in this form, I can get the X and Y intercept so easy. You saw how I did that. So I recommend that, but you can do it whatever you want to do it. But now to get the slope, I would go do this. I mean, I'd solve for Y. I probably would. I'd solve for Y so I could see, okay, there's the damn slope, you know? The slope is right there in front of the X. The slope is the number in front of X when it's in this form. Not when it's in this form, right? You're not going to tell me the slope is 5. Some people do that. They think the slope is the number in front of X, but only when Y is by itself. Only when you get Y by itself, then that number is the slope. What if I did my slope formula? Watch this. I can try this. You know, the slope formula is subtract your 2 Y's, subtract your 2 X's. I mean, do you have 2 points? Oh, here, I do have 2 points. I have an X intercept and a Y intercept. Huh. How do I subtract my 2 Y's? Subtract my 2 Y's. I guess I could go 0, this Y, minus this Y. Watch this. 0 minus, oh my God. 0 minus negative 15/4. Or if you don't mind, I'm changing it to negative 3.75. Is that okay with you? Mm-hmm. I just changed that. I'm sorry. To a decimal. 0 minus that over X minus that. So 3 minus 0. So this is my slope, a positive 3.75 over a 3. If you divide that with a calculator or whatever, what is that? You know what it is. It's your 1.25. You guys do need calculators. It's 1.25, right? Which is, again, just another... I'm sorry, I did this problem 6 ways, didn't I? Right? Sometimes students don't like 6 ways. Give me one way to do it. They don't. But I'm showing. I like to show you options. I like to show you how it all ties together. But I love that question. I usually do this. I give you a line in this kind of form, and you can do this. You can sketch a graph and answer these questions. It's pretty easy, I think.
Does that usually only work easily with linear equations? Or will it apply to future stuff?
Well, what applies to future stuff is the concept of if you want an X intercept, let Y be 0. If you want a Y intercept, let X be 0. That applies to all math, right? Then the work involved in finding, I mean, by the way, you're supposed to let Y equal 0 and then solve for X. The work involved in solving for X will be more difficult when it's not a line. It was real easy to let Y be 0 and solve for X. But it gets a little more difficult with when you get X squared and X cubed. Okay. One of the most, so I think I'm kind of easing into 1.4 now. And when I go to 1.4, I kind of, the questions get backwards. We're still talking about lines. But what you've seen me do so far is I've given you the equation. I say, hey, here's an equation. Now, sketch me a graph and answer all my questions, please. But I give you the equation. So what happens in 1.4 is we love to do these backwards questions where you have to find the equation. So that's a typical problem. Find the equation of the line. And if I give you, watch that. So here's a typical problem that goes through the point 6, 7 and has a slope of 4. You may have learned some different skills in the past. I will tell you this. When someone says find the equation of a line, what I need to have a point and a slope. Did they give me a point and a slope? Yeah. Well, then I'm ready to go. But what I need is this other formula. I feel like I got this other formula. It's called the point-slope formula, coincidentally. And the point-slope formula is this. Y minus y1 equals the slope times x minus x1. And this is another formula for a line. It's called the point-slope formula. It's not that great for graphing or for anything. This is a good formula for graphing or for learning about a line, knowing the y-intercept, knowing the slope. But this is good for this kind of question, when you're working backwards, when someone wants the equation of the line. What you do is you fill in the slope right there, of course. You fill in the point, where the point goes. The point is your x1, y1. You put your x1, y1 in for your point. You guys following me? And then your variables, because an equation has to have variables, so your variables are your y and your x. Those are your variables. So here I go. I'm plugging in the point, I'm plugging in the slope into this formula, and I'll have the equation of the line. Here it is. Y minus the y-coordinate of the point. The y-coordinate of the point, 7, equals the slope, 4, times parentheses, x minus the x-coordinate of the point, 6. If I have a point and a slope, I can plug it into this formula, and technically I could say, hey, there's the equation of the line. That's the equation of the line. We don't like to leave it like that. Can we distribute it and clean it up?
Yes.
But technically that's the equation. But let's clean it up. Distribute the 4. 4x minus 24. Add 7, right you guys? Add a 7, right? Y equals 4x minus 17. That's the equation of the line that meets their requirements. By the way, nobody said graph the line. That wasn't the question. I could have graphed the line. They gave me a point and they gave me a slope. You know, when you have a point and a slope, I guess you could go sketch a picture of it. Sketching a picture of it isn't what I wanted. I wanted the equation. And so I needed a formula. How do I get the equation of a line? And we've got this cool formula. If you have a point and a slope, you plug in your point for x1, y1, you plug in your slope there, you leave your variables y and x right there, and you get the equation of a line. Given a point and a slope, you can get the equation of a line. That's cool. That's powerful. And I like that a lot. So let's try another one. I love these so much that I've developed this shorthand. Instead, I got to write find the equation of the line. I mean, that's how all these problems start. So I'm going to say it different. I'm going to go like this. Find the equation of the line. Is that okay with you? Fatito? Fatito. Find the equation of the line. This time I'm going to give you something a little different that goes through the points 5, -1, and -3, 4. That's pretty cool, you guys. This is pretty awesome. You know, yesterday we did a good lecture and we started I told you about the 4 ways we like to talk. What did I say? An equation, some data, a graph, and word problems. Well, anyway, so what I'm doing to you here, I'm giving you some data. I'm giving you 2 points, and I'm asking for the equation. I'm not asking for the graph. I'm not asking for a word problem. Are you with me? But I am giving you sort of some data. I'm giving you 2 points on the line, and I'm asking you for the equation of the line. This is your buddy. I'm saying this is your buddy when someone wants the equation of a line. So, but what do you need? You need a slope and a point. Damn, they didn't give me a slope. Oh, but they did give me 2 points. If you have 2 points, you can find the slope. All right, thank you. So step 1 is we got to find the slope using our other little formula. So by the way, in this chapter 1, we have stumbled onto a few formulas, right? We got this one now. We got the good old y equals mx plus b that we've been using. And we got this old slope formula we've been using. So I kind of got these three formulas here for lines that I like to work with. But so when they gave me these 2 points, I think step 1 of this problem is find the slope. You guys agree? Am I talking too fast? You guys with me? Step 1 would be find the slope. Once I find the slope, I can use my point slope formula to get the equation of the line. But first I need the slope. The slope is 4 minus -1. I'm subtracting my y's. Are you guys all right?
Mm-hmm.
Over, subtracting your x's would be -3 minus 5. Gotta be careful with all those damn negative signs. Anyway, that's a +5 in the numerator and a -8 in the denominator. That's good for me. That's I like to call that -5/8. You guys okay? So that's my slope. And if I have a slope and a point, I can use my point slope formula and get the equation of the line. I want the equation of the line. Hey, I can use my slope and a point. You know, they gave me 2 points. Which point would you use? In this formula, which point would you use? The truth is, it doesn't matter. Half the class could go do that point, and they do their math, and the other half of the class could use this point. We do our math, and in the end, we get the same equation. It's the same line. It's the same equation. Doesn't matter. Here I go. Y minus, I guess I'll use this first point. So y minus a -1 equals the slope, -5/8, times parentheses, x minus the x value 5. You see how I did that? Point slope formula. This is good stuff. This is 1.4. Please practice this and get good at this. This is all over the first test. Find the equation of a line. By the way, we got the equation of the line. This is it. But nobody likes to leave it like this, so we like it cleaned up. So let's clean it up. That's actually y plus 1. If I distribute, it's a -5/8 times x. It's a +25/8. That's how you multiply fractions. You know how to multiply fractions? Multiply numerators, multiply denominators. Hey, now I'm about to subtract 1 though, so that means I'm subtracting a 1. Now I need a common denominator. A 1 is like a 8/8. I'm subtracting an 8/8 from 25/8. My answer is -5/8x. When I subtract 8/8, I get 17/8. Are you guys okay? If you don't like fractions, you could have done decimals and picked up a calculator and done some decimals. I mean, way back here, this slope is -5/8. What is that? Is that a nice decimal or a bad decimal? What is that?
625.
Maybe. 675 or 625. Calculator. All you need is a calculator. Nobody has a calculator, huh? It's cool to have a calculator. All I'm doing is 5 divided by 8. Yeah, 0.625. -0.625. I mean, I don't know if that would have helped you. What would that have done? You could avoid working with fractions. You could plug that, you could distribute that, you can add decimals and subtract decimals instead of adding and subtracting fractions, I guess. Whatever. Arguing about decimals and fractions is kind of beneath us, right? I shouldn't even facilitate that. Sorry. I mean, we should be comfortable either way, I suppose. But I happen to know students. I know students aren't that comfortable with fractions, and so I'm trying to show you that maybe you could work with decimals and be happier. But don't lose the big concept. Don't let the fractions lose the big concept. Given 2 points, can you get the equation of a line? Step 1, get the slope. After you get the slope, use one of those points and your good old point slope formula. Yep, that's the strategy. Right. What about this? Find the equation of this line. But this time, I don't think I'm going to give you data. This time, I think I'm going to give you a picture. Look at this picture. And I guess I'm going to label this, what should I label this point?
0.
That's 0, 0. You're right. It's called the origin, or 0, 0. And then this point, I went up 3 over 3, or I went over 3 up 3. I guess I'm going to label this 3, 3. Anyway, I wonder if you can get the equation of that line. Oh, shit. Oh, excuse me. I mean, essentially, thank you. Essentially, I gave you 2 points, didn't I? It's not really even a different question. It looks different because I gave you a picture. Right? I gave you a graph, but when it really boils down to it, I basically gave you 2 points. You know, what I said, when you have a question that says find the equation of the line, you ought to use your point slope formula. I keep erasing it, I guess. You know what this point slope formula is good for? It's good when you know the slope and any old generic point. But if you happen to know the slope and the y-intercept, well, then I would use this formula. Are you guys with me? I mean, if I just know any old generic point, I kind of need that formula, because that works with the slope and any old point. But if you happen to know the y-intercept, then and the slope, then you could just plug in the y-intercept, and there you are. You're done. You know, what is this slope? You could say it's up 3. I can just see it. I can calculate it. There's a lot of different ways to think, you know, you guys, but I can sort of see it. It goes up 3 and over 3. What is this slope? 1. It is. Up 3 and over 3. It's 3 over 3. It's 1. It sure is. I can do the math. It's 3 minus 0. 3 minus 0. That's a 1. The slope is 1. What's the y-intercept, you guys? The y-intercept. It is 0. So here I go. I'm going to use this equation, and I'm going to write y equals, the slope is 1, 1x plus 0. So I'm done. That's the equation of this line. This is a pretty famous line. He's got a slope of 1, and he goes through the origin, and he's just y equals x. He's a perfect diagonal line, perfect diagonal, perfect 45-degree angle, even though we're not really discussing angles in this class. It's a 45-degree angle between there. That's a famous line, y equals x. It's got a slope of 1. What about this? Watch this. Here's a word problem. My car was worth $12,000 when I bought it in 2010. every year it depreciates. Every year since then, it depreciates. It loses value. It depreciates at $685 per year. Or do I have to say per year? I already said every year. Every year it depreciates $685. And guess what? I think I want the equation of this line. So this is kind of a word problem, but I want the equation. Again, when someone asks you for the equation, I started 10 or 15 minutes ago, I said when someone wants the equation of a line, this is your buddy. But I'm sort of backtracking. This can also be your buddy. It depends on what you know. For both of those, you need the slope. But if you happen to know the y-intercept, then you're done. If you don't know the y-intercept, but you know some other point, then you use that formula. You with me? Mm-hmm. But if you happen to know the y-intercept or the starting value, and so yesterday I haven't done word problems yet today until now, but yesterday I was trying to get you to read a word problem and see a starting value. And then I wanted you to equate the starting value to the y-intercept. I did. And then I also wanted you to see a rate of change, like some kind of rate of change, and I wanted you to equate that to the slope. Good. So do you see that in this problem? A starting value of 12,000. Now that's if we start in 2010, which the problem ought to say, in 2010, we're going to call that year x equals 0. But that'll help you, help you realize that's the starting value. Yes, that is the starting value. And what is the slope? Do you see a rate of change?
Negative 685.
Good. Every year it's losing money at $685 per year. That is what that says. That is a rate of change. It is. $685 per year. It's losing value, and that's why he said negative. He said negative 685. So that's my slope. So dude, you read a word problem and you see the slope and the y-intercept and you write the equation. Y equals, you got the slope and the y-intercept. It's negative 685 x plus 12,000. Is that what I want to do?
Mm-hmm.
That's awesome, ain't it? I mean, I don't know. I think it's awesome. I think it's awesome. When you could make a sort of a real life connection, to this math, this slope and y-intercept. Hey, in a word problem, I usually have 3 questions. By the way, this goes on all semester too, but let's go ahead and start it now. I usually have 3 questions when I give you a word problem. The first question is, please come up, find the equation, because you need the equation. So, guess what? We sort of just did that. You understand? We found the equation. So that's part A. So part B then is this. Part B and C want you to use the equation, and part B says, hey man, what's it worth? What's my car worth? What is my car worth? What is my car worth in 2015? So what would you do? Plug in 15. Plug in 5. Plug in 5. Because 2010 was called x equals 0, and that's kind of what made this equation work. Because watch, if you do plug in a 0, what do you get when you plug in a 0? You get your 12,000. See, you need this to be a 0 for this to be 12,000. I mean, you need that to jive. So anyway, yes, because 2010 was x equals 0, 2015 is x equals 5. So you're saying plug in a 5. Is that what you're saying? That's what you're saying. It's easy, isn't it? Plug in a 5 for x. Again, a calculator would help, but I am plugging in a 5 for x. Negative 685 times 5 plus the 12,000. I mean, it's decreased in value. Yeah, he's right. Plus the 12,000 is 8,575. You're not supposed to do it in your head, but unless you're trying to show off. Is that right? No? She says no. It is right?
I got it.
Yeah, you might have done something wrong. 5 times 685 plus the 12,000. Oh, it's negative 685. So that's going to be a negative number plus that number.
Yeah, I'm getting 2225.
Huh. I don't know either.
Because the negative number is smaller.
Yeah, the negative number is small. Okay, so negative 65.
Times 5. Oh wait, you did 1,200. You need one more. That's what you did.
Ah,
One more 0.
there.
Yeah. That's what you get. Cool. Hey, part C. Next question, part C. Watch this. When, see the word when? When I ask when, what do you think I'm looking for? A time. Now I'm probably looking for a time, which is, what's time in this problem? It is years, it's X, right? So before I even written the question yet, but I wrote the word when, which means I'm looking for time, which I think it means I'm looking for X in this problem. But watch what happens. When is my car worth nothing? Might be never worth nothing, but according to this linear depreciation here, it actually will hit nothing at some point. When will it hit nothing? I mean, I guess can you interpret that sentence for me, please?
X equals 0.
Y equals 0.
When y is 0, the value of the car is y, by the way. When the value of the car is 0, find x, right, the year, or the time, right? Right? So now I'm letting y equal 0 and finding the value of the car, right? So now I'm solving for x. Again, look at these, anyway. This third question always takes a little more work. It was easy to plugging in an x and finding a y is easier than plugging in a y and finding an x. Yeah, whatever. It's not that much easier, but it's subtly different. Now I got to solve for it. Got to do a little algebra. Move the it's easy algebra. Move the 685x over. It equals 12,000. That's how I do it. I moved it over here. I divide by 685. So 12,000 divided by 685 is the answer. It's a bunch of years. It's
18 years.
what is it?
18 years.
18 years. Can you tell me 18 point? Give me one decimal. Or is it 17?
It's 17.5.
Well, 17, excuse me, yeah.
It's 17.5.
17.5. Are you rounding that correctly?
Yes.
Okay, thank you. 17.5 years. Okay, thanks. I don't know, I just might want tenths of a year just to refine it a little bit. Then it's worth nothing. That's a real typical question, man. I present a word problem to you, and from the word problem, you're supposed to be able to maybe get the equation. If you can see a starting value and a rate of change, you can get the equation. If you can see a starting value and a rate of change, you can get the equation. And then once you have the equation, you can answer questions. And my typical questions are, here's an x, find y. And then the other question is, here's a y, find x. I mean, are you with me? I mean, and again, this is this problem, but it's kind of typical for the whole semester. We kind of talk like this. Sure. Okay, go ahead.
Are you going to take on the quiz that says when? Or are you going to say, is it 20, 27? And so like,
Oh, that's true. I mean, it does take this many years, and then, yeah, some students, the truth is I'm happy you did the math
okay,
correctly.
you just want to find.
But you're right. What year will that be? That'll be, let's see, yeah, you're right. 2027, approximately June or so. Anyway, but yeah. I'm happy. I'm really happy if you did the math. But translating it back to what the word problem means is also kind of important. But I usually don't worry about that. All right, you guys. Listen, it might be time for a little break. Let me just check roll. I printed out a new roll today, so help me out here. Roxana. Okay, thank you. And Elisa anyway, she's not here, I guess. Raven.
Here.
Raven is here. And Jordan. And Jacob. And Angelica.
Here.
And Daniel. And Syed is missing. Shelby, no. And Rachel, and Ronald, no. Ernesto, and Christopher, and Michael, Matthew, Crystal, and Ryan Smith, and Sierra. All right. Anybody sitting here I didn't call? That would be bad. That means you think you're in your class and you're not really in the class. Okay, good. We're up to 18 people, but we're missing a few today. Okay, let's do this. Let's take a little break. Let's do 5-7 minute break. We'll come back and do a little more work, and then we'll have a nice long weekend. But let's do a little break first.